All right, just a quick review of the Unit 1 or Unit 7 review sheet, the Part 1. This is one we went over in class today. So just a quick reminder, trig has to deal with the right triangles. So you have to have a right triangle to use it. That means SOHCAHTOA. So if you remember, we talked about SOHCAHTOA. Okay, so given a right triangle, right triangle here, we want to find our reference angle first. We want to locate our sides, so across from it is the opposite, okay? The leg that's attached to that angle is the adjacent, and then the side across from the right angle is the hypotenuse. So sine, if you remember, is the opposite leg over the hypotenuse. Cosine is the adjacent leg over the hypotenuse, and tangent is the opposite leg, okay, over the adjacent. All right. Second question, which we're going to see a little bit of here, is the angles of elevation and depression. So if we have a person who is standing up high, like on a tower or on a hill or on a cliff, and they have to look down, that action looking down, okay, is, let's see if I can help with the light here, is going to create an angle of depression. All right. The person who's in the bottom, walking and has to look up, is going to create an angle of elevation. Now remember, we said that these angles are congruent because they are alternate interior angles. All right, so keep that in mind here. And remember, we always want to put that angle down in the bottom corner here. So if they give you angle, elevation, or depression, we're always putting it in the bottom corner of our right triangle. Also keep in mind that if it's at the person's eye level, you're going to have to add that distance, whatever you want to call it, we'll call it D here, right, to that to get the entire height here. So if he was walking around from his, like it was, he's like 5 feet off the ground, and he looks up, we can calculate the height to his sight line, and then we have to add 5 feet to that. Remember, also, now this is a little older version of the calculator here. Up in the top corner, you're going to see a DEG up here, okay? So as long as you see that, that's what you're looking for. If you don't, just move your cursor up here. You can press the button, go down to document settings, and make sure it says degree, okay? If it doesn't say degree, you're going to move it easy, but there we go. Or if you think that something's messed up here, remember we talked about go down to restore, and then it'll say, do you want to factory defaults? Click OK. Change float 6 to float, so that gives you the most decimal places possible, and change radian to degree. That's all you have to change. Go down to make default. Do you want settings for all the documents? Yes, we do. Okay, and then we can just open up a new document. No, we don't want to save, and then we can use your calculator. Okay. Remember that the menu for trig is the trig menu. So the top one is when you're looking for a side. The bottom is when you're looking for the angle. Okay. So we'll make sure remember that we're in degree mode. All right. So you're looking up here for the DEG, okay, and then just make sure this is degree, and then float. All right. Okay. On the next page. So with this question, just be careful. We know which equation we can use to solve here. So given this 20-degree angle, 12 is the adjacent and x is the hypotenuse. So if I were trying to set this up, we got our SOHCAHTOA, and I would want to do cosine of 20 is equal to A, so 12 over x. And so I can see that C matches my answer. If I did this and one of the answers, the answer didn't show up, I would want to go check the other acute angle, the one over here. And so I would say, well, that's 70, right? And now this would be the opposite in the hypotenuse. So this would be sine of 70 is equal to 12 over x. So if I didn't see that answer, I'd want to check this one, okay, and see if it works. And notice it does say cosine, but that's not what we're looking for 70, so just be careful. For number 2, we're just going to cross multiply here. So just throw 1 underneath. We're going to get x times the sine of 72 is equal to 15. Sorry for the light if it's messing up a little bit here. And then we just divide by the sine of 72, and we get our answer. This is nearest tenth, so just plan that accordingly. So 15 divided by trig, sine 72. We're in degree mode, and then nearest tenth, so it's going to be 15.8. Okay. What's e written as a fraction? So sine of e. So remember that's the opposite over the hypotenuse. So the sine of e is just going to be equal to 4 over 5. That's what we mean by fraction. Okay, what's the ratio? For the next one, we have 3, 4, and 5 as a right triangle. We want the tangent of A. There's my angle. That's opposite and adjacent. So the tangent of A is equal to 4 over 3. Okay, another triangle, 5, 12, 13. I'm going to do sine of A plus cosine of B. So from A, the sine of A is the opposite over the hypotenuse. Okay. Cosine of A, my bad. And then adjacent. So the sine of A is going to be 5 over 13 plus the cosine of A, which is 12 over 13. Remember, when you add fractions, we add the tops. So 17 over 12 add the numerators, and then keep the denominator the same. So 17 over 13. Number 6 in the accompanying diagram, it's giving us the information here. All right. Interesting. We are going to want to solve for x. So remember, right triangle. So my options here are law of sines or SOHCAHTOA. Not Pythagorean theorem because I'm not dealing with side lengths here. Okay, so we'll just bust out with SOHCAHTOA for today. So finding 48, I have the opposite side, and the adjacent leg, opposite leg and adjacent. Remember that's TOA. So tangent of my angle is equal to the opposite, 16.3 over the adjacent, which is x. Cross multiply, so x times the tangent of 48 is equal to 16.3, and then we want to divide by the tangent of 48. Remember, this is not just 48. The tangent of 48 is a number, it's a ratio. Okay, it's a decimal, so just be careful. All right, so 16.3 divided by the tangent of 48, and we get 14.67. We want nearest tenth, so that's 14.7. All right. On to the next one, and these are just 3 more of the same thing here. So for A, same thing. There's my angle. This is opposite and the hypotenuse. So we're going to do the sine of 26 is equal to x over 74. So 74 times the sine of 26 is equal to x. And then I'm just going to use my calculator. And we get 32.4 to the nearest tenth. For B, I have my angle, I have the opposite and the adjacent. So the tangent of 37 is equal to x over 44. We just cross multiply again. So 44 times the tangent of 37. And I get 31.15, so that's 31.2. And the last one, we have 56. We have the adjacent and the hypotenuse. So this is going to be cosine. That's x over 92. Just cross multiply. And then 92 cosine of 56. That's 51.44. So that's just 51.4. You only look at the next number. So even though this is a 5 and it would put, you would say like, well, that rounds that up to a 5. No. If we want to round to the 4, we only look at the next immediate number. And that 4 or less stays, 5 or higher rounds this one up, okay? All right, Dennis, who is eye level, 1.4 meters above the ground. There's my man Dennis. Okay, so this is 1.4 meters from there to the ground. There's my ground. Stands 40 meters from a tree. All right. And the angle of elevation of a bird on the top of the tree. So he's looking right like this, walking, has to look up, creates an elevation. That's a 30-degree angle. And we want to know how far above the ground is the bird, so that's this side. So remember, we're going to have to figure out x, but remember the total height to this bird, okay, all the way down, we have to add x plus 1.5 onto that, or 1.4, sorry, to get that height. Okay, so x only goes from there to there, and we have to add the 1.4. So if you remember our special right triangles, you could use this here. It's going to be a little bit of work because x radical 3 is going to equal 40, so we're going to have to figure out that one. The other option, the one we're sticking with here, is just SOHCAHTOA. So there's my angle, that's the opposite side, that's the adjacent, okay? So we're just going to do the tangent of 30 is equal to opposite, so we're calling this x over 40. Now don't get cute and do x plus 1.4. That's going to make this so much harder. Just figure out this piece first from here to here and then add the 1.4 at the end. If you do plus 1.4, you have to distribute the tangent of 30. You have to subtract that away and then divide out. It creates a lot more work, okay? So figure out this first, then add on to it. So cross multiply, we get x is equal to 40 times the tangent of 30. All right, and we want nearest tenth. So 40 and 30, that's 23.1. And then the actual height is 23.1 plus 1.4, so that's going to be 24.5, and then that's meters, okay? Number 9, Kendall spots a boat in the water. She's standing on top of a cliff, so there's our cliff. There's Kendall with her long flowing hair, right? You got a guy down here yelling out, "I'm on a boat." All right. The cliff from there to there is 40 meters high, and Kendall's eyes are another 1.8 meters tall. So the angle of depression from the boat that is level with the base of the cliff, that means that the base of the cliff is right here. It's level with that. Okay. So from her looking down, okay, this is 34 degrees. But remember, we're always going to put it down in this bottom corner here. All right, that's where we're going to put it. Not inside the triangle. So we want to use the one in the triangle. Also keep in mind that the actual height of this entire length is the 40 plus the 1.8. So this is 41.8 meters tall. And we're looking for how far away the boat is. So we want to do tangent because we have the opposite side. And the adjacent leg of 34 equals 41.8 over x. So we cross multiply and then divide out by the tangent of 34. And x is going to equal and how far to the nearest meter? So that would be 28 meters. Okay? You won't have to do number 10, but I'll just talk about it real quick. It's on the worksheet, so in case you're curious. Okay? Regular hexagon with a radius of 8 centimeters is inscribed in a circle. Inscribed means it's drawn inside. So the radius is the distance from the center to a point on the circle. So this line here is 8 centimeters. Okay? Now, if we were to draw all the radii in, we would essentially create 6 equal or congruent triangles. And each of these angles here, okay, has a degree measure, since these are all equal, and around a sixter is 360, is 360 divided by, essentially, right, the number of triangles. So this angle, for our purposes, 360 divided by 6 is 60. All of these are 60-degree angles. Okay, Now, to figure out the length of this side, in a hexagon, and regular, meaning all the sides are equal, this would just be 8, because this, if this is a 60-degree angle and these are equal, these have to be 60, so this is technically an equilateral triangle. But let's pretend for now that we didn't know that. What I would want to do is drop an altitude down in the triangle. And what that's going to do is it's going to cut the triangle directly in half. All right? So what I really want to know is what's this piece right there. Because ED, right, is just 2 times whatever that is. So if I had a 30, 60, 90 right triangle, I could remember if that's x, this side is 2x, so x is 4, 2x is 8. Or I could bust out some SOHCAHTOA and do the sine of 30 is equal to x over 8. So 8 times the sine of 30 is equal to x, and then that'll spit out 4. And so then we know that ED is equal to 8. You can do that right on the other one here. Okay, so the Pentagon, this one's not going to be as nice. We want to cut this into triangles like we did last time. And I know I'm going to get 5 triangles. So the central, it's called the central angle, is 360 divided by 5, which is 72 degrees. So when I draw the altitude in here, these two pieces are going to be equal. Okay, the side length, ED, is actually 18, so each of these is going to be 9. This is 36, and now I'm looking for the radius, I'm looking for this side. So I'm going to use sine again, because I have the opposite side over the hypotenuse. So the sine of 36 is equal to 9 over x. So x times the sine of 36 is equal to 9. Divide up by the sine of 36, not just 36. And I get x is equal to 15.31, and nearest 10, so it's 15.3. And this would be in centimeters. Okay. Find the missing side lengths. So in a 30, 60, 90, remember the pattern is x, 2x, and x radical 3. Okay, so if this is 6, that means x is 3, and that this is 3 radical 3. And if you forgot, we could do some SOHCAHTOA. Okay, so I could do the sine of 30 is equal to a over 6. So 6 sine of 30 is going to equal a. That's where the 3 comes from. And I could bust out Pythagorean theorem. So a squared plus b squared is equal to c squared. And 3 squared plus 6 squared is equal to b squared if you need to. Okay? Time out. B squared is equal to 6 squared. Sorry. All right. So we'll finish this off. So 9 plus b squared is equal to 36. B squared is going to equal 27. And remember, when we square root it, and we want to do simplest radical form, okay, we're going to do either menu factor or just go down here where the letters are and just type in the word factor. Okay, but otherwise it's menu and then 2, 3. And we'll type in 27. We can see it's 3 3s. So b is equal to 3 times 3 times 3. A circle is set. So b is equal to 3 square root of 3. Okay, same thing here. Now these are 45, 45, 90. Remember the pattern is x, x, x times the square root of 2. And I'll give you that on the sheet. You'll see it tomorrow, okay? So if this is 3, that's 3, and this is 3 radical 2. And if you forget, right, we could bust out with, the sine of 45 is equal to what we would want to do, 3 over b. So you can figure out that b is equal to 3 divided by the sine of 45. And then you can do Pythagorean theorem again. I'm not going to finish that one. We know what the answers are for yourself. All right, 14, copy diagram below. We got the stuff listed. Find the length of BC. So we'll put an X there. once again, this is the adjacent, that's the hypotenuse, so that's going to be ka, right? So ka toa, that's cosine. So cosine of 52 is equal to x over 18. We cross multiply. 18 cosine 52, and that's 11.08, nearest 10, so that's 11.1. All right. Number 15, find the height of the tree to the nearest 10th. So angle of elevation. So now what happens is this. It casts a shadow. So what happens is the sun is chilling up here. Our tree, right, is hanging out here. And there's a shadow on the ground that's casting. So, all right, the angle of elevation would be if you were on the ground looking up. It's 33 degrees. There's no one standing here, so this is just to the ground. Okay, we know that the shadow is 62 feet, so we're looking for that side. So this is adjacent, and the opposite, so that's tangent. So tangent of 33 is equal to x over 62, and then x is going to equal 62 times the tangent of 33. So just cross multiply. That did not register. 62 tan 33, and we're going to the nearest 10, so that's 40.1, and this is in feet. And there you go. 16. A ship cast out at sea is 352 meters from the base of a cliff. So once again, all right. The angle of depression from the top of the cliff to the ship. So there's no height involved here, so it's just creating that right triangle. Remember, depression is this guy, but we're always putting it down here. So that's 38 degrees. What's the height of the cliff? This is another tangent because it's opposite and adjacent. So the tangent of 38 is equal to x over 352. We cross multiply. So the tangent of 38 times, right? Don't forget those parentheses. All right. So if you do the tangent of 38 first, make sure you close those parentheses, all right? Times 352. And we get 275 nearest meter. So 275 meters. All right. Jack approaches his work, spots a cat on top of the building. So the rooftop is 20 meters from the ground. So that's 20 meters. All right. Once again, Jack, his eyes, just looking this way, are 1.5 meters from the ground. If the angle of elevation to the cat, yep, not drawing that, is 59 degrees, how far is the Jack from the building? Is Jack, so that's this guy. So same thing, we want to figure out this distance. Remember though that the actual height of the building, I don't think we have to need anything with this. 1.5 really doesn't affect us. That actually it does. When we draw our triangle, we have to remember that this 20 meters is not the side of this triangle, okay? This is the triangle we're looking for. So this height is 20, and now we have to take away Jack's eye height of 1.5. So this is actually going to be 18.5 meters for that height, just from Jack's eyesight to the top where the cat is, okay? So this is what we're going to have to use, this 18.5 instead of the 20. So we still want to do tangent because it's opposite adjacent of 59 degrees is equal to 18.5 over x. We'll cross multiply, and we don't have x by itself here, so we have to divide out by the tangent of 59. And we're going to get x is equal to and we want nearest meter, so that's 11 meters. Okay. In the diagram below, we know the triangles are similar. If the triangles are similar, this means that the sides are proportional. So that means that the sine of A, okay, the sine of A, which is this guy, is equal to the sine of D in this triangle. So whatever the ratio of the sides in A are, they're equal to the ratio of the sides in D. So if I were doing the sine of A, that would be BC over AC. And that's equal to the sine of D, which is FE over DF. So the sine of A is actually equal to both of these, BC over AE and FE over ED. Okay, or EF over D, what do you say? Sine of D. FE or EF over DF. So like you see the first one, right? And you see how that's DE instead of DF. So we know that's out. Okay? So we can do the cosine. So what is going to happen a lot in these questions, okay, is that they're going to ask you for the tangent of C, but it's actually going to be the ratio from this triangle. So the tangent of C is the same as the tangent of F. So the tangent of C is the same as the tangent of F, tangent F. And the tangent of F is DE over FE. Okay? And look at that's off. Okay? All right, the sine of C is the same as the sine of F, right? So the sine of C equals the sine of F. And the sine of F is DE over FD or DF. And you see, like, that's not right. So let's try the last one. The tangent of D would be the same as the tangent of A. So the tangent of D is the same as the tangent of A. And the tangent of A is BC over AB. And so we know that's our choice. So we have to go through a lot of those, but I hope you get the idea. When they give you these two triangles and they ask you for the sine of C, almost always you're looking for the other triangle and make the ratio there. Okay? And number 19, a little bit tougher as well, given similar triangles. If the sine of A, so remember the sine of A is opposite over the hypotenuse, then that means that the opposite side from A is 4 and the hypotenuse is 5. We want to know the value of x. Now we know that these two angles are equal. So from this angle, this is the adjacent side and this is the hypotenuse. So if we give this a name, let's call this angle, we'll call this angle B, okay? That means that the cosine of B is equal to x over 11.5. Remember, these two triangles are similar, okay? So the cosine of this angle B, we'll call this B prime, is also the same as the cosine of B prime, which is 4 over 5, okay? So that means that this ratio is equal to that ratio. So 4 over 5 is equal to x over 11.5. And now I just cross multiply itself. So 5x is equal to, we get 46. And we divide by 5. And we get 9.2. And that's the value of x. So when you're doing two similar triangles, just remember that the sine, cosine, and tangent of one angle is equal to the sine, cosine, and tangent of the same corresponding angle in the other figure. Okay? So if this was A, this is also angle A. Okay? So the sine, 4/5 of this, right? And they give us this. This is cosine and then cosine. So that's all we're doing is setting those equals. And that's it for that sheet. So hopefully that helped you guys. I'll do another video in a second here for the other one, and we'll put that out when it gets there.